In the previous class, what we were studying refraction. Yeah? We were studying refraction. So let's study the further part of this chapter. Okay. So in the previous class, we were discussing the refractive index. And what is refractive index? What is refractive index? Can anybody in the class tell me? Everybody, please turn on your camera, please. It's my request. But everybody, please turn on your camera. I'm just going to open the focus mode, activating the focus mode. Now I can only see you. Okay. So let's start. Let's start. In the previous class, what we were studying the refractive index. Refractive index. Okay, and there are so many important questions that come from this question. Refractive index is sine I by sine R, or we can say that it is the ratio of sine angle of incidence when a light ray passes from from one medium to another medium. So it must have it have some angle of incidence with the normal, which is angle I, and then it bends. If it is moving from rarer to denser medium, then it bends towards the normal. Like it might be going like this, it might be going like this. Okay, but it bends towards the normal. It is called angle of refraction. Okay, are you understood? So every time when we are just going to calculate the refractive index, that is the ratio of the angle of incidence to the angle of refraction. Got my point?
Yes, sir.
Okay. Now moving to the next point is it is also the ratio of refractive index can also be defined, and it is defined by mu. Okay, that is constant. That is constant. Mu is constant for particular substance. For example, for water, if I am having water, then the value of sin I will be constant. Similarly, refractive index is also equals to speed of light in one medium, speed of light in medium one, divided by speed of light in medium two, speed of light in medium two. Okay, and actually this type of refractive index is called relative refractive index because it is relating the speed of light with one medium to another medium. Okay, now if I'm saying that there is if we fix the first medium, then this will become absolute refractive. This is called relative refractive index, and now this has become absolute refractive index. Absolute refractive index. And absolute refractive index is simply we have just fixed the speed of light of the first medium. That is the speed of light. It is the ratio of the speed of light in vacuum, sometime air also, to the speed of light in any other medium. You understood? Okay, absolute refractive index means we have just fixed the first medium, that is the medium one will be always at the speed. We can say that in the numerator we are going to have the speed of light in air or in vacuum, that is going to have a value of 3 into 10 to the power 8 meter per second. You understood?
Yes,
everybody understood? Okay. Now moving to the next point, let me explain you here. Have you written all this? Copied this? The value of absolute refractive index will be always greater than 1. The value of absolute absolute refractive index will be always greater than one. Why it should be greater than one? Why it should be greater than one? Can anybody clear me? Why it should be always greater than one?
Because the numerator will be less than the denominator, the angle of incidence will be less than the angle of refraction.
Yes, you can easily understand this one. That the speed of light in vacuum is maximum. Whatever the speed of light in the another medium like glass, water, any medium, second medium can be anything. So the speed of light will be lesser than the speed of light in vacuum or air. So if the numerator is the if you are saying that the numerator is highest or is greater than the denominator, so value will be greater than one. Okay, got it? For example, if it is being written that the refractive index of diamond is 2.4, it means that it is absolute refractive index is being given to it. Okay. So if it is being given that the refractive index of a diamond it equals to 2.4. Okay. And that of speed of or I'm saying the speed of and that of glass is 1.5, that of water is 1.33, and so on. Okay, so what is this? This is given to us that it is the absolute refractive index. You understood?
Yes, sir.
Got it? Clear? Okay. So now moving to the next point is that whenever we are just calculating the absolute refractive index, so questions comes to us that sometime it is being given that, and how it is pronounced. Let me explain you that how it is pronounced. If the light is traveling from air to glass, so it will be given that the refractive index of glass with respect to air. Okay, you need to keep in mind the refractive index of glass with respect to air, that is written as mu. Here air and there will be g. Okay, or it can be written like this, mu g a. Okay, it can be written like this. So it will be equals to 1.33. Okay, you need to keep in mind what is written with the things which is given respect. For example, a refractive index of glass with respect to air. So if it is given with respect to air, so it means that you have to keep the speed of light, the things that is given respect, that is called air. Okay, and the speed of light, I think that is written here. Okay, that is glass. So mu a to g is or a to g. Okay, you understood? Got it? Means light is traveling from air to glass. Okay.
Yes, sir.
Is there any doubt regarding to this point? Everybody understood? Hashik? Ammar? Understood?
Yes, sir.
Please note it down. Please note it down. Done. Is I'm audible?
Done, sir. Yeah, yes, sir. You're audible.
Okay. Is my screen is visible to you?
No, sir.
No. Okay. So let's move, dear students. Let's move to the next topic. So here it is being written like this way. So if I'm saying that mu G to W, okay, so means nothing that is written at the top, you have to write here the speed of light in glass with, okay, to W. But can anybody tell me that it is written as a refractive, is it absolute refractive index or the relative refractive index? This one is absolute or relative?
Relative refractive
Yes, it
index.
is relative because the speed of light, in the numerator we have the speed of light in glass, not the speed of light in water. Sorry, not the speed of light in air. Means the ratio of speed of light of air to the speed of light of water should be there. In the numerator we don't have the speed of light in air. So similarly, if it is written like the refractive index of water with respect to glass, the thing that is being given as a respect, okay, we have to put it in the numerator. You understood? Understood? Okay, got it. So now you need to keep in mind here, if I'm saying that the refractive index of glass with respect to what? A glass with respect to water. Okay, the thing which is given, respect. Refractive index of glass with respect to water. Okay, so the thing that is, should I pronounce this one? If I'm writing the glass, is it which one is correct for the pronunciation? Refractive index of glass with respect to water, or refractive index of water with respect to glass? Which one is correct for this one? Which one is correct?
Refractive index of water with respect to glass.
Okay, then very good. The thing that is being given respect with respect to glass, the thing that will be written here. Okay, that thing will be written. Okay, so everybody clear this statement?
Yes, sir.
Okay, so let's move further. Let's move further. Now, if I'm saying that it is being said that mu G to W is equals to X. Okay, then mu W to G will be equals to 1 by X. Or we can say that mu G to W is equals to 1 upon mu W to G. You understood? Got it? The refractive index of glass with respect to water will be equals to the refractive index of glass, means it will be equal when you write it in 1 upon. Okay, got it? Means it is the reciprocal of this. Got it?
Yes, sir.
Got it? For example, if it is being given that the absolute refractive index of glass is 1.5, then what will be the refractive index? Then what will be the refractive index of air with respect to glass? Can anybody in the class tell me?
1 by 1.5.
Yes, it will be. So absolute refractive index means that it is air to glass. That is 1.5. And what is being asked here? That what will be the refractive index of air with respect to glass? Means glass should be here and air will be here. and that would be equals to, if the A to G is given, then G to A will be 1 upon 1.5. Everybody clear? Is there any doubt regarding to this one? Hashid, Ammar, clear?
Yes.
Okay. Okay. So let's move. That if it is being given that, sometime it is given that spellings are not giving you. Okay. Let understood this topic. This is important. For example, if a light is passing from one medium to another medium, let's suppose if it is passing from, this one is air, this one is glass, then glass, before after the glass, this is turpentine, or let it be water. Let it be water. Okay. Water. Now the light is passing from air to glass. You know the refractive index of air is 1, because 1 upon 1 is 1. Okay. What's the refractive index of glass? That is 1.5, and that of water is 1.33. Okay. So tell me, if the light is passing from the air to glass, will it bend towards the normal or away from the normal? Will it bend towards the normal or away from the normal? Tell me. If the light is passing from rarer to denser medium, you know that this is the rarer medium, this is the denser medium. So tell me, will it bend towards the normal or away from the normal? Tell me.
Towards the normal.
It will bend towards the normal. Yes, it is bending towards the normal. Okay. Now this is 1.5 and this is 1.33. Now again it is passing from rarer. Now tell me, will it bend towards the normal or away from the normal? In this case, now it is from glass to water. When it moves from glass to water, will it bends towards the normal or away from the normal?
Okay.
Yeah, slightly away from the normal. Okay, slightly away from the normal. It will bend slightly away from the normal. Why? Because this is 1.5 and this is 1.32. So more the refractive index, note it down, more the value of refractive index, more will be the denser medium. Okay, now tell me, if I ask you, this is medium 1, this is medium 2, this is medium 3. If I ask you that in which medium the speed of light is maximum?
Medium 1.
Medium 1. And in which is the least?
Medium 2.
Medium 2. So simply, more the denser medium, or we can say that more the more more the refractive index, lesser will be the speed of light. Got it? You understood? Lesser will be the speed of light. Okay, i.e. speed of light is inversely proportional to refractive index of the medium. You understood? Note it down, please. Note it down. Done? Ashid, Amar,
No, sir.
done? No? Put it down.
Done, sir.
Clear? Okay. This type of question is being asked so many times. Okay. Now coming to the point, if I'm saying that here you see that the light is traveling from air to glass. So if I'm writing here, the path of light that is traced air, mu air to glass into then it is passing from glass to water. I'm writing here glass to water and then from water to air again. Okay, then water to air again. Then the product of the three refractive index will be equals to 1. Okay, means if this one and this one, the first one and the end one is same, means the light is started traveling from air and then it comes out into the air. Okay, and this GG portion and this WW portion is same. So we can simply say that if you start producing, if you start multiplying these refractive index, you will get the value as well. For example, if I just take only two mediums, like this, light is traveling from air to glass, then it bends towards the normal, and then again it comes to. So if I'm writing here mu air to glass into mu glass to air, that would be equals to 1. You understood? Got it? So here it comes like this way. So I was just saying mu air to glass is the reciprocal of glass to air. So it just comes, it will comes down. So this come it from here. Okay, that is a statement that I was saying that is the reciprocal of this one. You understood? Understood?
Yes, sir.
Okay. So let's move further and let's do the numerical problem regarding to this one. Okay. Let's suppose if it is being written, if it is being given that mu air to glass is 1.5, or you can write it 3/2, and mu glass to mu air to water, or the absolute refractive index of water and absolute refractive index of glass is 1.33, that is equals to 4/3. Got it? So if I ask you calculate the relative refractive index, index of mu glass to water. So how will you able to calculate this one? So now you need to trace the path. You have to write the formula in the correct manner, and then you will be able to get this value. Okay, so how will you write? What you need actually, you need mu glass to water. Okay, mu glass to water. So note down that whatever being written here, write here the G. Then multiply sign, then mu, and whatever written here, write here W. And then write their common medium. There will be always common medium like A. So write here A, write here A. Okay, you understood? What is being written? Let me explain you again. Whatever being written here, G, so write here G. If it is W written here, write here W. Multiply. Okay. And then write their common medium, that is A. Now you can write A to G. So if G to A. So if this is being given to you, that is the value A to G is given to you, then what should be the value of G to A? Tell me, what should be the value of G to A? Ashid, you understood? Are you getting my point? Abir, Ashid, Amar, are you getting my point? Tell me what should be the answer of this one?
Yes.
Tell me,
Sir,
dear student,
can you hear me?
how? Yeah, I can hear you. I can hear you. Yes, if I'm saying that mu A to G is 1.5 or 3 by 2, then what should be the value of G to A?
2 by 3.
Yes, it will be the reciprocal of this one. I've told you it should be the reciprocal of this one. Okay, so it should be written like mu A to G is, you can write that if A to G is given in the question, then you have to write here G to A. Why G to A? Because it is being asked G to W. The refractive index of water with respect to glass is being asked. So you have to write here the value of G to A, that should be 2 by 3. Okay, that should be 2 by 3. If A to G is 3 by 2, then the value of G to A will be 2 by 3. Into A to W is being given to you at right here, same, that is 4 by 3. Then you will get 9 by 8 by 9. You got it? So here is the refractive index of. Got it? Got it? Understood?
Yes.
Yes, sir.
Please note it down in the copy.
Done, sir.
Okay. Ashik done? Amar done? Hmm? So we'll do the questions regarding to this one also. Okay. Left. So let's you please help me in solving this question. Okay. I'm going to give you the absolute refractive index, absolute refractive index of glass is 1.5, and the absolute refractive index of another one of a material is 1.2. Calculate the absolute refractive index. Calculate the relative refractive index. Relative refractive index of material with respect to Is that audible?
Yes, sir.
Calculate the absolute refractive index of the material with respect to water. With respect to dust. Respect to dust. Do it by your own. Do it.
Sir, I got 1/6.
You got 1/6. Okay. Done. Other. What's it solving? Hashid, try to turn on your camera. Why are you hiding yourself? Hashid and Ammar.
No, so my laptop gets stuck. So if I turn on the video, so can you hear me properly? Hello,
Yeah,
sir.
yeah, I can hear you.
Okay.
Wait a minute. Wait a minute.
So your screen is not visible.
Yeah, I know this. Still not visible? Or is it visible now?
No, sir, it's not visible.
How is it?
Okay. Actually, at my when I used to take the class, there's on the next floor over it. There is some work is being done, and because of that, drill machine is working. So because of that, I just shifted myself to some other place. And that's I'm just facing a little bit problem because this is a coaching area, and after the class here is ended, so the sweeper come and he need to sweep everything. Okay, so I need to shift from one place to another place, and now the class everything is over. So my charger was in this classroom, and I was just taking the class, and suddenly it showed the battery low, and then his laptop is. In the previously, what happened? I just suddenly shut the lid of the laptop, and then again it goes on the sleep mode. So that's why I was facing a little bit problems. Okay. So now you understood. Let you solve this problem. So uh, it is being asked that absolute refractive index means mu air to glass is 1.5 is given to you. Absolute means the first medium should be here. Then absolute refractive index of a material, let the material be M and the first medium will be A, and it is 1.2. Then what is being asked? Calculate the relative refractive index of material with respect to glass. The thing that is being given to you, respect in the respect that you have to write here. Okay, and the thing that is not given or that is written before the respect, you have to write here M. Okay, now write it like this. What you write here? G, write G here, into write M, into M here. Then the common medium for the both is A, and right here A, A. Now what you need to write? It is being given A to G, then you have to write here. That is 1.5, but here it is A to G. But so you have to write here 1.5. Okay. Into then you have to write here 1.2. 1 point. Got it? You understood? Then that will be 1.2 divided by 1.5. Got it? Clear?
Yes, sir.
Done? Done?
Yes, sir, done.
So when you cut it, you will get 6 by, sorry, when you cut it 12 by 15, and then you will, when you cut it, you will get divided by 3, you will get 4 by 5. Okay, got it?
Yes, sir.
If I ask you a simple question, okay, now let's take the question from the from this topic so that you can understand the concept of this chapter. The question. So we should take the question from this topic. Okay. This is being given to you. The refractive index of diamond with respect to glass is 1.6. And the absolute refractive index of glass is 1.5. Find out the absolute refractive index of diamond. Do question number 24. Please note it down in your copy. And then do question number 20. Calculate this question number 24. And put the value. This one. Are you solving? Ammar, Hashid, are you solving? Ammar,
Yes.
Sir, 2.4.
2.4. Okay. Hashid and Ammar, done? Or should I help you? Hmm? Done? Should I help you? Ammar, done or not done? Okay, let me help you. So what is being given to you? The refractive index of diamond with respect to glass. So the thing that is being respected is glass. So right here G and diamond is here. G to D is 1.6 and the absolute refractive index of glass. So absolute means A should be here and glass is here. That is 1.5. What is being asked? Find out the absolute refractive index of diamond. Means A to D is being asked. Absolute, when it is absolute, then you have to write here A in diamond is being asked. So when it is being asked, so write here A, D, then write here A, and then multiply sign, then write here D, and their common medium that is glass. G and G. Now, what is being given to you? A to G. A to G is given 1.5 into G to D is also given, that is 1.6. So when you multiply these two, you will get 2.4. Got it? Got it?
Yes.
Yes, sir.
So next question from this topic. Here it is given that the how is the refractive index of the question number 23? How is the refractive index of medium related to the speed of light? So you know that the speed of light in one medium to the speed of light in another medium is the will gives you the refractive index. Okay. Obtain the expression of the refractive index of medium with respect to another medium in terms of the speed of light of the two medium. So you can do this one. Hmm. Now, some questions that I can give. Another question. And now the law of reflections we have done this one. Earlier. Now let's study the important topic that is TIR, total internal reflections. Okay, that is an important topic. TIR. Let's study this one. Okay, I'm just checking the question if there are any question related to this topic that we have done. Okay. So let's move in the first. Let's now the next topic is TIR, total internal reflections. Okay. Let's you know that when a light is passing from denser medium to rarer medium. Okay. That a light ray is passing from from denser to rarer medium. Okay. Then what is happen? What is going to happen? That it will bend away from the normal, let it bend from away from the normal. Okay. Got it? Let it bends away from the normal. Okay. That is I here and that is R. The light is traveling from here to here. You understood?
Yes, sir.
Understood?
Yes.
Okay. Now, if I increases the angle of incidence, let's suppose if I increases the angle of incidence to some more angle, then it will bend again away from the normal. More I, more will be the R. You have to keep in mind, this factor is very important, that it is not possible that if I'm writing sine I by sine R, okay, more the value of I, more will be the value of R. It is not possible if you are increasing the value of I, whether the light is moving from rarer or denser medium. It does not depend. If you increase the value of I, the R will automatically increase. So let it bends more away from the normal. Okay. Then I pass another ray. Let's suppose if I pass and just it comes over it. Just the angle of R is such that it becomes 90 degrees. Got it? Got it? Now if I slightly increases a little bit angle, then what would happen? What is going to happen? The light will bend and comes into its own medium. This is called TIR, total internal reflection. It's called TIR, total internal reflection. So what is total internal reflection? When a light is passed from denser to rarer medium. You can't do this one with the, let's suppose if I'm going to, what is the main condition for TIR? Let me explain you. If a light is passing from rarer to denser medium, let's suppose a light is passing from rarer to denser medium. Let's suppose this one. So whatever the value of I is, okay, the value of R will be smaller than the value of I, because when the light passes from rarer to denser, I is greater than R. So the maximum I, if I could take the angle of 90 degree, and if I take the angle of incidence 90 degree, then the value of R will be lesser than 90. So it will not come back to its original medium. So for TIR, what is the main condition is that the light should pass from denser to rarer medium. Got it? What is the main condition? First condition is light should pass from rarer to denser. And moreover, let me explain you. This angle, the angle at which the angle of incidence, if I'm passing this light from denser to rarer medium, okay, and let for some angle of incidence it become 90 degree. The angle of refraction become 90 degree. So that angle of incidence will be considered as critical angle. Means what is critical angle? Let me explain you what is critical angle. What is critical angle? The angle of incidence. The angle of incidence at which the angle of incidence at which the angle of refraction becomes 90 degree. Okay. So if it is 90, so if I just slightly increase the angle greater than critical angle, then the next ray will come to its original medium. Okay. The next ray, if I just slightly increase the angle of incidence greater than critical angle, then the light will come to its original medium. Okay, that is called TIR, total internal reflection. Now the reflection is started. TIR means now what is going to happen here? The reflection is started, not the refraction. Refraction was when the light passes from one medium to another medium. Here the light is coming to its original medium. Got my point? Got my point? You understood?
Yes, sir.
Okay, so let me explain you here. Okay, what is TIR? Okay. So note it down. The phenomena due to which a ray of light while traveling from optically denser medium. You have to keep in mind that you have to write the optically denser, the word optically, because the denser medium, mass density, a medium, if it is mass denser, it is not necessary that it is also an optical dense. Like in case of turpentine and water, I have explained you that water is more denser in terms of mass density than turpentine, than kerosene. Okay, but according to the optical density, or in terms of optical density, turpentine is more dense, optically dense. So you need to keep in mind that when a ray is traveling from optically denser medium to optically rare medium, this is the first condition, and get reflected into optically denser medium. Again, it get reflected to optically denser medium at the surface of separation is called total internal reflection. Okay, now write down the definition of critical angle also. The angle of incidence in denser medium for which the light, the angle of reflection becomes 90 degrees is called critical angle. Note down the definition of TIR. When you're done, please let me know. Please make the diagram also. Done? Abir?
Yes, sir. Just the diagram is left. Done, sir.
Done? Everyone? Hashid, Ammar, done? Hashid and Ammar, done? I didn't get you. You turn on the mic. Tell me my voice reach. I didn't get you. Done, Ammar?
Yes.
Hashid, you done? So let's move further. Condition for TIR. Let's write a condition. The light must travel from denser to rarer medium. The angle of incidence should be greater than critical angle. Note these conditions for TIR. These are important for the examination point of view. When you're done, please let me know. Done?
Yes, sir. Done.
So here the difference between the reflection, normal reflection from the mirror and the TIR. You know, TIR, total internal reflection, is being used in the optical wire that is being used for transferring the internet from one region to another region, one place to another place. Okay, so we use optical wires, fiber optics. Okay, you know, fiber optical wires that is being used. So in this, the light is means the data is being transferred with the light, and that is TIR is being done in the wire. The light is being transferred from here to here like this way in the wire, and then it reaches to the end without major loss. Okay. So what is the major, or what is the difference between the reflection through mirror? Like if I'm just refracting it from the mirror, and then the reflection done by TIR. We can say that Refraction is done means when smooth surface is required. You know that smooth and polished surface is being required, then the reflection is going to take place. And here, no smooth and polished surface is being required. You know that TR means simply light should travel from denser to rarer medium, and then it's okay. Okay. So please note it down. And next one is it takes at all the angle of incidence. For example, you are taking a mirror, okay, and any angle, if you are having an angle of 30 degree, then it will pass, the refraction will take place at an angle of 30 degree. But here the total internal reflection take place above the critical angle of incidence. Means if the angle is lesser than critical angle, so TIR is not going to take place. Okay. And here it is, some light is being absorbed by the mirrors or some light wastage take place, but here no light is being absorbed by them. Okay. So please note it down, the difference between TIR and reflections.
Done.
Done. Are we still writing?
Yes.
Done. B. Done.
No, sir, just a minute. Done, sir.
So please take the screenshot of this one, and this is the applications of TIR. The one most application of TIR is that because TIR is going to, we are just going to complete, we will start the spherical mirrors in the next class. So here it's TIR. So you know that TIR is being used. The application, one application is that it is being used in the optical wires for transmission of that data without the wastage of energy. And second, diamond sparkle. You know that diamonds are being cut in such a way because diamond is going to have the highest refractive index, that is 2.4. So it is being cut in such a way that the small angle of incidence, okay, the lights bend inside it, and it results in, means because diamond is going to have the highest refractive index. Because of that highest refractive index, its critical angle is just 24. Means if an angle greater than 24, if light is entering into it, okay, at an angle greater than 24, so simply it is going to reflect and it will behave like a mirror. So glittering of diamond or sparkling of diamond is just because of TIR, that is, and diamond is going to have the highest refractive index. Okay, so please take a screenshot of this. I'm going to leave in the next class. Okay, done.
Yes, sir.